Number 85. Which of the following gases diffuse more slowly than oxygen? And then they give us all of these different gases. So basically we just have to find out which one of these diffuse more slowly than oxygen. Now, diffusing just means movement of gases throughout a closed vessel. So like, let's just pretend that here's my closed vessel, and I have oxygen being this little, blue dot here. Diffusing would just mean to basically move around the vessel. Will oxygen diffuse slowly, meaning it will move very slow, or will it be able to diffuse fastly by moving very fast, right? So we want to know which one of these, or maybe some of these, are going to diffuse slower than oxygen. And notice that I put O2, right? I didn't just put O for oxygen, because remember, oxygen is one of your diatomics. So we're going to basically list out O2, right? And that's the oxygen. And maybe I will just, maybe I'll just put this over here. That's kind of like a, remember if you guys want to draw it or whatever. But now here's the important part. In chemistry, if you want a faster rate at which your molecule or compound is traveling, that means that you have to have a low molar mass. So if you want a faster rate, if you want your molecule, and going back to this flask, if you want your molecule to be traveling very fast throughout the tube, the molar mass of that gas has to be relatively very low. If your molar mass is very high, it's got a lot of weight, so it's going to take a longer time and less speed to travel throughout the gas. So all it is just looking for those molar masses. So let's just list them out. So we need to know the molar mass of O2, and then we need to know all the molar masses of these guys. So let's list them out. So we got, maybe I'll start it over here. So we have Fe, F2. We got Ne. We got N2O. We got C2H2. We got NO, Cl2, and we got H2S. Okay. And here's the one we want to compare. We want to compare oxygen. So we got to have a starting point. We got to know what oxygen's molar mass is. So oxygen's molar mass, if we look on the periodic table, it would be 32, right? 32 grams per mole. And maybe I'll just move this a little bit over here. Okay. So now, if we want to diffuse more slowly, that means that my rate should be decreased. So what does that mean in terms of the molar mass? I'm looking for a higher molar mass, and that's what the specific question is here. So if we want to go more slowly than oxygen, we need to have a higher molar mass. So let's go for it. F2, 19 times 2 is what, 38? 19 times 2, 38. So we found one already. So I will highlight the ones that are slower. So F2, since it has a higher molecular mass, or a higher molar mass, it will diffuse more slowly. Ne is just 20.18. So it's faster because it has a lower molar mass. N2O, 14.01 times 2 plus 16. Hold on, 16 plus 20.02. 44.02. So there's another one because it has a higher molar mass. Okay, let's keep going. Now we got C2H2. So 12.01 times 2 plus 2 times 1.008. I get 26.036 grams per mole. That one's not going to diffuse slower because it has a lower molar mass. We want a higher one. NO, 14.01 plus 16. I get 30.01, still not, it's lower. So that one's not going to diffuse more slowly. Cl2, by far, yes. 35.45 times 2 is 70.9. Way slower. So there we go with that. And then finally, H2S, I get 32.06 plus 2 times 1.008. And I get 34.076 grams per mole. So it just beats it. So it will diffuse slower. And there you go. So F2, N2O, Cl2, and H2S will all diffuse more slowly than oxygen because it has a higher molar mass. And there you go, guys. Hopefully this helped. Let me know in the comments. Subscribe to the channel if you want to help us out. Just gets the word out there that this educational channel exists, and I think it's pretty cool. So yeah, hit the button. Thank you, and I will see you all later. Have an awesome day. Bye-bye.